All right, so we're going to multiply rational expressions. Really just multiplying fractions is what it is, but multiplying rational expressions. Here we go. First of all, before we get to the multiplication part, we're going to learn how to simplify them or put them in lowest terms. And here's basically the rule. When you have a fraction that has multiplication in it, you're allowed to multiply you're allowed to cancel the common factors like those two C's they just canceled out. Do not cancel with addition, but you can cancel when they're factors or they're multiplied together. Quick example right here, if you have 15 over 65, which you're kind of used to doing from way back, you could break the 15 down 3 times 5 or 65 13 times 5. Then you can cancel the 5's because they're multiplied, not added, and that just leaves your 3 13s. Now that's not usually how you think about it. You usually think about it probably just like, okay, what goes into 15 and 65? 5 does. Let's take a 5 out. How many times is 5 going to 15? How many times is 5 going to 65? It works that way really well. More algebraically is this one where, if you notice on the numerator and denominator, you only have one term each place because they're factored, and you can cancel the x plus 3's because they are factors, not because they're added to anything. And what that leaves is just 4 over x minus 5. So that's kind of where we're heading today. Let's go look at a couple. First problem just says simplify. X squared minus 2x minus 15 over x squared minus 9. What you're going to have to do first is factor them. You need to be good at factoring today and tomorrow and really the rest of your life. So I'm looking for factors of negative 15 that give me negative 2, and that would be x minus 5 and x plus 3. Then 5 must be negative because the 2 is minus. On my denominator, I've got a difference of squares, so you can write that x plus 3, x minus 3. And now that I have factors, I can cancel things. So I can cancel the x plus 3's. That's all I can cancel, which leaves me with an x minus 5 over x minus 3. I want you to remember this answer for the next slide. I'm going to show you something that people do that I don't want you to do. All right, what not to do. What not to do. This was the answer on our last slide, x minus 5 over x minus 3. Do not be the one who does this. Do not be the one that cancels those x's because you can't, because they're not factors. Those two numbers are added together or subtracted. You cannot cancel subtraction, addition, only factors. So don't be the one that does that. We've had that discussion before way back, but don't cancel those. All right, multiplying. When you multiply, basically, when you multiply fractions, the rule is you multiply the numerators and you multiply the denominators. All right, and then simplify. And it's your choice how you do that. You can also cancel before you multiply. You've been taught that before, I'm sure, in middle school. But we're going to concentrate today pretty much on multiplying the numerators, multiply the denominators, and then simplifying after that. All right, let's try one. We're actually have two here. I want you to watch pretty closely as we go. Always start by factoring, so I'm going to take the top of this one, take out a GCF, which is 3x, and if I take out a 3x, that leaves 1 minus x, and my denominator I'm looking for factors of negative 5 that give me positive 4, which would be x plus 5 and x minus 1, times, I can factor this numerator, x plus 5, x minus 4, which is good, and on the bottom here, they're already factored 3x. Now what I'm looking for there are things in my numerator and denominator to cancel. And if you want to, you can write it. You don't have to do this step, but if you want to, you can write one big fraction with everything on your numerator and everything in your denominator all over one big fraction here, x plus 5, x minus 1. And I have that 3x, so I'm going to put it in the front. And then what you can do is you can just, cancel any factors that you can. So I see 3x, that's gone. I see x plus 5, that's gone. Now, one thing we haven't been over, 1 minus x and x minus 1 are opposites of each other. And the reason they're opposites is because they all have different signs. This one is positive, the one down here is negative. This x is negative, this x down here is positive. And because they're completely opposites, you can cancel opposites. Think about this. If I have 4 over negative 4, that's negative 1 because you can cancel the opposites. So I'm going to cancel the opposites, but when you do that, make sure you include a negative 1. Because when you cancel them, that's what you get. So what that leaves me with is a negative 1 and the next minus 4. And if I distribute that negative 1, it gives me either negative x plus 4 or 4 minus x for my final answer. All right, so that's a really good problem. I want to watch that one again. All right, last slide. This is one I wanted to show you that has a fraction times just a polynomial. Okay, and I think you know what I'm going to do here. We're about to find out. All right, what I'm going to do first is factor my denominator. Oh my gosh, it's cubes. When you factor cubes, remember small, big, cube root, square the first one, multiply together, change the sign, and square the second one. So that is how you factor cubes. You can remember that. Now, a polynomial, if there's no fraction, it's really the same thing as having this polynomial over 1. Now, that won't factor. There are no factors of 9 to add up to be 3, so I'm kind of stuck right there with what it is. But what I'm noticing is, look what I have down here. The same factor as what's up there. So what that leaves me with in my numerator is just an x plus 2. In my denominator leaves me a 1 times x minus 3, which is x minus 3. And that's your answer. Again, don't be the one who cancels those x's out there in your final answer. They're not factors. You can only cancel factors. I think I made that pretty clear. Okay, really all we're doing tomorrow is multiplying fractions and simplifying them. And we'll do plenty until you get really good at it. And I'll see you then.